Hello there, welcome to A-Level Maths Applied June 2023. Here we're looking at the stats question 2. A machine fills packets with sweets and 1/7 of the packets also contain a prize. The packet of sweets are placed in boxes before being delivered to shops. There are 40 packets of sweets in each box. The random variable t represents the number of packets of sweets that contain a prize in each box. State the condition needed for t to be modelled by the binomial distribution with 40 trials at a 1/7 probability. Okay, so the answer to part A is that as you choose each box, it needs to be independent. So the choice, the success of picking a prize is independent of how many boxes you've already picked. And the 1/7 probability needs to remain constant as you continue to pick packets of sweets from the machine. Okay, so part B, a box is selected at random. Using t is binomially distributed with 40 trials 1/7. Find the probability that the box contains exactly six packets containing a prize. So what we want to work out here for part B is the probability that t equals 6 exactly. So we're going to need to do that on the calculator. So go to mode 7 on your calculator that says statistical distributions. We want the binomial PD mode, with P for precise, a precise probability of 6 packets. Let's go to variable now. We don't want to make a list out of this. So we want to work out the probability of getting 6 packets out of 40 with a 1/7 probability, and press enter, and the answer is 0.173. And there we are, that's the answer for part I. Moving on to part II, the probability that the box has fewer than 3 packets containing a prize. So if it contains fewer than 3, then that means t needs to be less than or equal to 2. And we need the binomial CD mode for that. So go to binomial CD for variable, and then we want 2 or fewer out of 40 with a 1/7 chance of success, and we get 0.0616. Both of those written to 3 significant figures. Excellent. So Camille's sweet shop buys 5 boxes of these sweets. Find the probability that exactly 2 of these boxes have fewer than 3 packets containing a prize. So this second part of the sentence here was the probability that we already found in the previous question. That was the 0.061587111 probability. And now we need to do a new binomial distribution where we're picking exactly 2 of these types of boxes out of 5. So what I'm going to do is I'm going to press the store button, STO, and then I'm going to select one of these letters from above. So I'm going to press store and then A. And what that will look like on your screen if you've done that correctly is store as A. Then I'm going to set up a new binomial distribution with 5 trials, and the probability of each success is 0.0616. And then I'm going to look for the probability that x is exactly equal to 2. So once I've stored that as A, I'll go back to binomial PD mode for precisely 2 boxes. And 2 will be my number of successes out of 5. And the probability, you can just now input your A value from before. That will make your answer as precise as possible. And the answer here is 0.0313. So there we are. Okay, moving on to, let's get all that out of the way. So Camille claims that the proportion of packets containing a prize is less than 1/7. A random sample of 110 packets is taken and 9 packets contain a prize. Use a suitable test to assess Camille's claim. you should state your hypothesis clearly and use a 5% significance level. So our hypothesis is that the null hypothesis always remains the same, so it's still 1/7, and Camille's alternate hypothesis is that the probability is actually less than 1/7. We'll need to use that t binomial distribution from before, so t binomially distributed, sorry, no, it's changed now, isn't it? It's not t, because we've now got 110 packets, not 40. So let's do y. Y is binomially distributed with 110 trials. We're going to assume the probability is still 1/7 and then test what the probability of picking 9 packets is if the probability was still 1/7. So y is the number of packets containing a prize. Okay, so we found that out of these 110 packets, 9 contain a prize. So what we're going to test for here is the probability that y is less than or equal to 9, because if 9, it's always a region that we're testing with the hypothesis test, and if 9 packets contain a prize is a low value, then so will 8, and so will 7, etc., etc. So we're always testing a region, and in this case, because the probability is being reduced, we're looking for the probability is less than or equal to 9. So let's get back to where we were out of that series of calculations. So here we are. So we're in binomial CD mode. We want to test for 9 packets or less out of 110 with the probability still being 1/7. And the answer to that is 0.0383. So we need now 2 concluding sentences, one that compares this value to 5%, and then one that brings it back in terms of the context of the question. So sentence 1, as 0.0383 is less than 0.05, we reject the null hypothesis. Because it's quite a low probability, less than 5%, so it's very unlikely that 9 or fewer packets contained a prize, so there's probably something to Camille's claim. Therefore, the evidence suggests, and I would encourage you to always phrase it like this, the evidence suggests that Camille's claim is correct. So there we are, that's the answer for question 2, worth a total of 9 marks. Let's now move on to question 3.